Okay, Algebra 2, Quiz 1 is day 5. There are a few things that wanted to mention before we jump in. With arithmetic sequences, arithmetic sequence means that there is a common ratio, or not a ratio, I mean a common difference between numbers. For example, you can have 1, then 3, then 5, and 7, so on. That's a arithmetic sequence because you're adding 2 every time. All right, so it's called an arithmetic sequence. There's also a geometric sequence. That means there's a common ratio between numbers like 2, 4, 8, 16, 32, where you have multiplied by 2. And this is just an example. Of course, you're going to have different kinds of ratios and different kinds of differences. That's a big difference between an arithmetic sequence and a geometric sequence. So, going on your quiz, for number 1, you have 14, 21, 42, and 77. And the question is this an arithmetic sequence? Well, you just take the difference between the first two, which is 7, then you take the difference between the second two, which is 21. Well, those aren't the same, so this is not an arithmetic sequence. There is no common difference, and that's how you do that. For number 2, you want to find the arithmetic mean of an, or I'm sorry, you want to find the arithmetic mean an of these two, an minus 1 and an plus 1, or a sub n minus 1, a sub n plus 1. So a sub n is actually going to be right there. So it's an arithmetic mean, and we know from what's given that a sub n minus 1 is 5 over 7, and a sub n plus 1 is 9 over 4. So in this arithmetic sequence, what goes in the middle? What we can do is just get the average of those two numbers, and we'll get the one that goes right in the middle. So you just add 5 over 7 plus 9 over 4 over 2. Alright, so let's clear that up there to get some room. So we're finding the arithmetic mean of those two numbers. So you can do a common denominator now, or you can just divide by 2 and get a common denominator later, however you want to do this. So you get 5 over 14 plus 9 over 8, because I just divided by 2, I multiplied the denominator by 2 essentially, and that's going to equal 20 over 56. I'm going to use 56 and 63/56, and then whatever that answer is my answer. 83 over 56 is my arithmetic mean of those two numbers. So 83/56 would go between those two numbers. I'll go right down here between those two. Alright. Number 3, grocery clerk sets a display. Okay, so we have a display, like you'll see in some stores. They kind of have a display like this. It looks like a setup of bowling pins, where it's triangular like that. Alright. And so if there are 15 at the base, how many do you have total? Alright. Well, in each row, like the first row, if there's one row, there's one case. So one row gives you one case. 2 rows gives you how many cases? Well, you have to add those up. That's actually 3 cases with 2 at the bottom. With 3 at the bottom, you have how many cases? 6. Right? 1, 2, 3, 4, 5, 6. So you're adding everything from before. So what's our sum going to be? So we want to add all those numbers with when you have a base of 15. Well, what kind of sequence is this? Well, you start with 1 can on the bottom, then 2, then 3, then 4. It's an arithmetic sequence because you're adding 1 every time. So the formula for summation for an arithmetic sequence goes like this. It's Sn equals n over 2 times the first term plus the last one that you want, which is a sub n. So a sub 1 is the initial term, and we want to find the 15th. How many are we going to have with 15 on the bottom? So we just substitute it. Substitute 15 for n. So S of 15 equals 15 over 2, because that's our n right there. We're going to multiply a1, which is, a sub 1. That's our first term, which is 1. We started with 1 on the top, right? And then we're going to add the last term, a sub n, which we said was 15 because we want 15 on the bottom. So everything else is just arithmetic. 15 over 2 times 16, which is 15 plus 1. We can cross cancel. 15 times 8 will give us 120 cans total. So with 15 on the bottom of a pyramid like this, you'd need 120 cases. So it's a way to get a sum really quickly without having to add up all these numbers. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 and everything else. Next one, describe the pattern in the sequence. Find the next three terms. Our sequence is 4, 8, 16, 32. What's the pattern here? It asks us the pattern. Well, obviously you're not adding the same thing, so now do we find a common ratio? Well, you have to multiply by 2 to get 8, and you have to multiply 8 by 2 to get 16, and so on and so forth. So your pattern is multiply by 2. That's your pattern. What are the next three terms? We'll just take this last term and multiply it out. So we just continue it. 64, 128, 256. Those are my last three terms, and those two are my answers for number 4. Number 5, it gives us another sequence. We have 625, 250, 100. You can see that's not an arithmetic sequence. So we divide them out. Divide the 250 into 625, and you're going to get 2.5. That's the ratio there. Is that the ratio between 250 and 100? Yes. So this is a geometric sequence with the pattern divide by 2.5. So you're dividing by 2.5. All right. And find the next three. Well, you just keep on dividing by 2.5. So the next three after 40 are going to be 16. And then divide again, and you'll get 6.4. And divide again, and you'll get 2.56. So those are your three numbers. This is like those are two different numbers there. 6.4 comma 2.56. So that's your answer there. Pretty straightforward. Number 6, write a recursive formula for the sequence 8, 10, 12, 14, 16. Now a recursive formula just means it depends on whatever the last number was. That's the difference between recursive and explicit. Recursive uses the number before to get the next number. So the recursive formula is a sub n equals a sub n minus 1 plus the common difference. So in this case, what's our common difference? It's just plus 2. Plus 2. Alright, so our recursive formula is a sub n equals a sub n minus 1 plus, plus 2, and we're done. We'll also add that our first term is 8, so part of the answer is also a sub 1 equals 8. That's our first term. So that's a recursive formula in the first term. All right. Then for 7, write the explicit formula for the sequence 7 to -3, -8, -13. So then we want to find ace of 14. Okay, we want to find that. We also need to get the formula. So the formula for any sequence like this, and let's see what kind of sequence it is, by the way. We subtract 5 each time. So it's an arithmetic sequence. And the explicit formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. Now d is the common difference. Common difference. That means what you need to what's being added or subtracted each time. And the common difference in this case is -5. That's our common difference. And so we have to just add that in. So a sub n in this case is going to be a sub 1 plus n minus 1 times -5. All right, now we distribute the -5. So then we get a sub n equals a sub 1 plus -5n, and then -5 times -1 is going to give +5. Now what's a sub 1 in this case? I'm sorry, there should be an equal sign there. What's a sub 1? It's 7. 7 was our first term. So we put that in. This will become 7. All right, now 7 and 5 can combine to be 12. So we get -5n plus 12. And that's our explicit formula to find any term. -5 times that number plus 12 will give us our answer. All right, so now we find a sub 14. It wants us to find this one right here. So we just plug in 14, and now it's just arithmetic. It's like Algebra 1. You just plug in stuff in. So a sub 14 equals -5 times 14 plus 12. And we have to multiply that out. And that's going to give us -58. And that's your answer. So here's your formula. Right there. Formula is right there. And for the 14th term, it's going to be 58 because we put it in the formula, and that's how we come about that. All right, number 8. Table shows the predicted growth of particular bacteria after various numbers of hours. Write an explicit formula. So our hours, which is n, and bacteria. So we have 1 is 19, 2 hours gives us 38, and 3 hours gives us 57, so on. So we know that our pattern is the first term is 19, 38. You can think of it like these are just separated by commas in a way. All right, so it's you're adding 19 every time. So what you're doing is you're going to use that same formula, a sub n equals a sub 1, which in this case would be 19, it's your first term, plus n minus 1 times the common difference, which is 19, as we have said. So now we just distribute the 19, and also we have to plug in our first term. So the first term is 19 plus 19 times n is 19n. We distribute the 19 also to the -1, which gives us a -19. So you get 19, this should be in there. 19 plus 19n minus 19, these two 19s will end up canceling. And so a sub n equals 19n. So it's just 19 times the number of hours, which is what, you can obviously that's true. For the next one, It's a formula a n equals negative 4 times n. Oops, sorry. Negative 4n times n minus 1. Is it explicit or recursive? And this is explicit. A recursive formula would use ace n minus 1 like that. Now, for the first 5 terms, we just put in 1, 2, 3, 4, and 5 for ace of n each time, and we just put it in for n here and here. So we just plug in 1, 2, 3, 4, 5. So ace of 1 will give us negative 4 times 1 times n minus 1, n minus 1 would be 0. So we get negative 4 times 1 times 0, which is 0. So ace of 1 is 0, and you do for each one of them. And ace of 2 is going to give you negative 8. Ace of 3 is going to give you negative 24. And ace of 4, let's see, let's get some room here. Ace of 4 is going to give you negative 48, and ace of 5 is negative 80. Okay? That was number 9. Number 10, find the 50th term of the sequence. 5, negative 2, negative 9, negative 16. So first of all, what kind of sequence is it? Well, you subtract 7 here, subtract 7 there. So it's an arithmetic sequence because it has a common difference. So what's the formula to find the nth term? Basically, it's ace of n equals ace of 1, that's the first term, plus n minus 1 times the common difference. Okay, so we just put in that. What's our ace of 1? It's the first term, 5 plus n minus 1, and our common difference is minus 7. So now we can multiply out and add like terms. So positive 5 plus negative 7 times n is negative 7n, negative 7 times negative 1 is positive 7. So we can combine those two together to give us negative 7n plus 12. So ace of n is negative 7 plus 12. 7n plus 12. And once we have that, we can find the 50th term. That was what it asked us. You'll find the 50th term. So we just put in 50 for n here, and then we'll get it. Negative 7 times 50 plus 12. That'll tell us what number it will be in the 50th term. So when we do this, we get negative, sorry about that, and then plus 12, so that's going to give us negative 350, and plus 12 is going to give us negative 338, which is the answer. Okay. Number 11, find the missing term in the sequence 22 blank 34. It's arithmetic, so again we just add them and divide by 2. And we get 28. 56 divided by 2. Then on the last one, it's arithmetic mean again. Ace n minus 1, ace n plus 1 are going to be separated by 1 number. So again, we just add and divide by 2. And that's going to give us 11 over 2, which is 5.5. You can write it as a decimal if you wish. And that's it. See you in the next video.